So, welcome everybody. It's my pleasure to introduce Daniele. He's here for this seminar on good cities.
Yes.
We hope Como will become eventually a good one. So I leave the mic to him. I will take the mic actually. Then at the end, if you want, you can ask questions and interact a little bit. You will see that some of the projects he's been working on are close to what we do, at least with some of us. That some of us do on city scale and event scale management. So it's a pleasure to have you here. Thanks.
My pleasure. Thank you for inviting me, and thank you guys for coming. I'll try to be to cover like 40 minutes. If you have to ask questions during the presentation, just do that. No problem at all. And if you want to ask questions later on, it's fine. But during the presentation might be best because I don't want to go on and then you're like, what did you say there? It's better to actually interact. All right, so good city life, that's the title of the presentation, and I'll tell you in a moment why we have that title. But let me tell you who I am. Daniele, I mean, most of you are Italians. Who is not Italian here? Or non-Italian speakers? Okay, cool. A few of you. Well, I'm sure that in your residence here in Milan, you found some people that are with a finally, and you find out that they are not females, right? So, but most of the times when I go abroad, most of the people expect a blonde showing up, and then they look at me and they say, wow, okay, that's not... the reason is because I come from Puglia, then I did my undergrads in Torino, in Politecnico, and then I did my PhD at UCL in London in computer science. So then I went for a postdoc at MIT in the urban planning department, and then I went to Cambridge. I was in the computer science department, computer lab. And then in Cambridge, in UK, I actually got fed up of the weather, and so I went back to Barcelona. And then I would really miss the weather, the bad weather in Cambridge. So I went back to Nokia Bell Lab. So we opened a new lab in Cambridge. So we are actually looking for interns. So if you want to apply, just apply by today because that's the deadline. Those are the projects. They're on my website as well, so you can see what we're looking for in terms of how to say skills, right? So there are different skills from different disciplines in computer science mainly, but also psychology and urban planning. So that's more or less where we are. So we work at Nokia Bell Labs. Bell Labs, you know, is an historical lab. They invented the transistor, Unix, all the stuff that you guys use, that you invent there. Smart city. So why? So clearly, this presentation is in the area of smart city. And what's the problem with it is that most of the companies, I work for a company, so I can badmouth companies. Most of the companies think about smart cities in terms of, so what is a smart city? A city where when you go to work, you're always going to be on time. When you go shopping, there is no queue. And you're going to feel really, really safe because of the CCTV cameras around you. Right? So it's about convenience, security, safety. Right? We all know that these things are important. Right? But there is a difference between something that makes a city acceptable and something that makes it great. The problem is that most of the work that has been done in the smart city agenda has been focusing on the acceptable bit, on the sensors, on making convenience, no traffic. But there are certain things that are very difficult to capture, but make a city great. Right? So now we're going to tell you a couple of examples of things that make a city great. But that's the reason why we started goodcitylife.org. Goodcitylife.org is a community of people, including us, that Milos and Anita, that we started it. And it's a community of people who want to do research on things that are totally orthogonal to the typical smart city agenda, right? So if you want to do sensor things and traffic, fantastic, there are tons of people who do that. If you want to do something else that is looking at this acceptable, the transition from acceptable to great, then that's what we focus to do. Okay, how do we do this? Well, most of the times when, especially when I'm supervising first year PhD students in Cambridge, what I say is that most of your 3 years, what you're going to learn, you're not going to learn very much anyhow in 3 years. You're just going to learn to steal. And also how to steal and from whom to steal, right? So clearly, I mean, this is not something esoteric or something weird because I'm not the first one saying that. Picasso said the bad artist imitate a great artist still, and Bansky stole that. Do you know all these people, or they are like... so Picasso you might not know. Yes. Okay. Bansky is a bit more modern, so it's a more an artist, a street artist, let's say.
Resuming the presentation. Thanks.
So yes, right. So we are here. So I was saying, okay, we need to learn to steal. So obviously, I stole as well. From whom I stole? From this guy, Jane Jacobs, Stanley Milgram, and Kevin Lynch. Do you know any of them? Do you know Jane Jacobs? I don't think so, unless you're an architect. Stanley Milgram, maybe one of you. Two? No? Okay. Stanley Milgram is the guy. Do you know the 6-degree experiment? Friends of friends. The world is connected by friends of friends 6 times, right? So he did that, but he did also some experiments in the urban context, and I will tell you one. And Kevin Lynch is an urbanist. So those are the 3 names from which basically we took their experiments that were done in the 70s, 60s, and 70s, and we basically rephrased them, but just we copied them, right? So, but we gave a totally different scale. Right, so I mean, the result of this token mechanism for 2 years has been one thing only, the application, and the application is that this is Boston, and the application of running, instead of giving you from A to B the shortest path, it will give you the short path that is happier, that makes you happier. And of course, all the research focus on what makes you happy, the psychological perception of things, right? Okay, so how do we capture the psychological perception of things? This is Kevin Lynch. So he wrote a book, and it's a foundational book in urban planning. And one of the things that he thought about was the idea of why is important the way you're exposed to different parts of the city, right? So if one part of the city, a lot of people are exposed to it, and another part of the city, there are not many people exposed to it, why is that important? Right? So he thought about it, and he wrote a book on it. And we've done a couple of papers, so if you're interested in details, I won't go into the details in the presentation, but if you're interested, you can read those papers, The Hidden City, A Finger on the Pulse. And the idea in these papers is that we use this oyster card. Do you know what the oyster card is? Have you been in London first? How many? Sorry to ask, so that is more lively. So, have you used the oyster card? By any chance? Yes, right? It's a good idea to use it because you pay much less. So it's a passive RFID. If you scratch it, you don't get the £5 back, but you find out that it's passive RFID. And the idea is that whenever you enter in a station in London, you open the door, right? There is money in there, and it's passive RFID. And when you exit, you tap in and you tap out, right? So virtually what you can get from the London Transportation Authority is an anonymous identifier when the anonymous identifier taps in a station and types out in another station. So visually you have single individual flows of people. So what we did, we took all the London Underground, there were hundreds of stations, and we basically did a graph analysis of the flow of people going from one area to the other, and then we match it with census data. And the census data tells us this area is poor, this area is well-to-do, and so on, socioeconomically speaking, right? And we found out this really simple thing. So we're speaking about flow of people in the London Underground. The London Underground is basically virtually used by 80% of the population, and matching it with census data. Right? So that's the outcome of the work. Okay? So can you interpret that outcome? Just an interpretation. It doesn't have to be right, because I don't consider my artistic skills very inspiring. But any of you. Hang on. So here there are socioeconomic data, right? So the areas that were and rich, let's say, and flow of people.
We have like that poor people stay in the poor area or go, but only one way in the richer part, and the rich people stay in the rich part.
Okay,
watching the windows.
Yeah, exactly. Or they make money and can go in the richer part, but then they stay in the richer part.
Right. Okay. Yeah, you've done the summary of the whole paper. So basically, the people who live in the private areas, they go to other deprived areas and to well-off areas, and people who live in well-off areas, they go to other well-off areas, right? So as you said, there is a sort of thing that the people in rich areas and well-to-do areas, they stay in rich areas, right? And this is actually the corollary of that is that the rich areas have a greater visibility because they're exposed to a greater number of people, no matter who, than the poor areas. They are exposed only to a certain segment of the population. So this is basically the bottom argument that the Kevin Lynch does in the image of the city. Far before us, we just try and test it on a different kind of data, right? And he has a definition as well on the visibility. And he defines visibility like the easy to reach city parts can be recognized and organized in a equation pattern, right? So the two keywords here in this definition are recognized and organized, right? What does that mean? It means that you can think about a certain part of Como or Milan, wherever you are, and you can recognize it, right? You can say, oh, this part is this neighborhood. And even you can place that part in the map. You can recognize and organize, right? So those are two different things. So the problem with that definition is that how could you possibly come up with proxies that are quantitative to measure visibility, right? So it's very difficult. So I can do a one-to-one experiment with each of you, and I can ask you, can you recognize this part? Can you organize on a map? And then I have to do it over and over again with all of you, right? And that's not a totally computer science way to do things because it's not totally scalable. And second, it's not the most optimal way, right? So there should be another way of quantifying that. Any thoughts on that? Because when I'm going to show you what Milgram did, then you're going to say, it's obvious. Okay, I'm going to show you the obvious bit now. So that was 1970, right? So 1972, Milgram, and you find most of his original articles in the middle of the world in this book, published a paper that was called Psychological Maps. And the concept was, can we quantify recognizability? Can I look inside the minds of people and say, these places are recognized and these other places are not recognized, right? And measure recognizability as well. So psychological maps, what is a psychological map in the first place? Anyone, just have a guess. Yeah, it doesn't have to be right again. I'm not giving you any information.
The first thing that you, let's say, imagine when you think of a place? San Francisco for me is blockbuster.
That could be one type of psychological maps, but even simpler than that. So more like why psychological? So it's a map, right? And it's psychological. So that means it's
places are not given by coordinate, but about concept or feeling.
Yeah, you're going even more sophisticated in what I'm looking for. So I mean, it's really basic. The answer you're looking for is more like it's a map that is inside your head. Then how you translate that, you can think about the related concept or how do you formulate inside your mind.
So your mental view?
Yes, it's the mental model that you have of a city, right? So it's basically a map of a city. And just to give you an example, this is San Francisco, as you said. And you can ask a person, right? So like Alice, if there are security people around, I'm going to use Alice and Bob with you guys. So Alice, you ask, what's your map of San Francisco, right? So you give a piece of paper to Alice, and Alice is going to draw the map, right? And he's going to say, okay, I look at San Francisco like this, right? So he's going to draw maybe some landmarks, maybe the port, and some things, right? Then you ask Bob, and the same city, and Bob is going to see a bit different, right? The point of this stuff is that if I ask thousands and thousands of people and I collect beautiful drawings, in addition to do art, I can do another thing. I can say, okay, can I derive a function that will basically do an average or an addition or an intersection of these maps? And can I actually capture the collective map that people have of the city? So you have a map of the city, you have a map of the city. In this room, we have a collective map of this city. Can I capture that? Difficult, right, to do with drawings. Okay, 72, genius, simplicity. Stanley Milgram came out with the experiment. He said, okay, he was teaching in New York back then. So he showed to his students for 90 minutes in his class different parts of New York and basically asked his students, can you actually guess where this picture was taken? picture after picture, picture after picture, picture after picture. Then the students were noting down where the picture were taken. And basically, he collected all the answers on a pen and paper, 72, and he went back home, and after 2 weeks, he came out with his own drew map, right? So those are basically, if you can see, I don't know if you can see from far, but those are little dots, right? So those are the dots where he sampled the pictures. And then the recognizability score, so basically the colors reflects the extent to which, the fraction of correct answers from the students. That means the darker it is, the higher the fraction of correct answers. So it means that the students could recognize really well Manhattan compared to Brooklyn and Queen, and yet there were parts of Brooklyn and Queen that were more recognizable than others, right? So clearly, you can capture, this is the first example of capturing in a quantitative way, the concept of recognizability, what people recognize inside their head. So now, if I tell you exactly how I did it, then you say, oh, that's obvious. But we started from the theory that was not that obvious how to capture this thing. And we said, okay, the surprising thing is that from 72 to nowadays, there's not been any study to capture that recognizability stuff, right, at scale. So we said, okay, what's the difference between milligram times in the 72 and nowadays is the web. So what we did, we wrote a paper that's called Psychological Map 2.0. So we copy even the title. Milgram had psychological maps, we added 2.0, that's it. Didn't do very much. And we built a website, it's called urbanoption.org. And basically the idea is to replicate Milgram experiment in a fun way. So instead of showing you for 90-minute pictures of the city, you are in London, let's say, and you get to show 10 pictures of London from Google Street View, sample at random, and then you have to guess where the picture was taken. You have a point on the map. Basically, it's repeating Milgram experiment, but it lasts 1 minute. Then you have a score. It's a game. You can share on Facebook, and your friends can adopt it. In a few months, basically, we had more than 6,400 people who from London play the game. Right? So we have basically their game scores. So we can quantify the extent to which they recognize different parts of the city. Basically, copy Milgram experiments, but at totally different scales, read not only undergrad. Okay, so this is London. This is the politically decided map of London, right? So those are the boroughs, in English, and then you have the cartogram. So the cartogram is an inflated version of, depending on the fraction of correct answers. So that means that if you recognize an area really, really a lot, then it's going to expand, right? So basically, this is the politically decided map of London. This is the map that people have inside their head. And it looks a bit different. So, in the sense that the south of London totally disappears. It doesn't exist in people's minds. And the central part, this tiny part in the center, they're totally the blue, right? So because people can recognize the center of London. It's touristic because there are landmarks and so on. And they can still recognize cases on Chelsea, which is one of the rich parts that is not totally center of the city. So, in a way, you say, okay, the politically decided map is different than what people have in their minds. When we're designing services, we're actually designing services having the politically decided map, not the map that actually people have, and then navigate the city. So that's interesting. But also in terms of scientific terms, mostly the idea was like, can we actually quantify the relationship that Milgram and Kevin Lynch hypothesized decades ago? That is, what you recognize is related to the socioeconomic condition of an area. So if an area is recognized, has got a different socioeconomic condition compared to an area that is not recognized, right? So that was the link. That was and now we have the data to do that. Not only we have the data to look at simple relationships, but we can look at relationships at different dimensions. So from the census data, this is London again, those little things, there are census areas in the city. And for each of those areas, you have the index of multiple deprivation, which is an index that is multiple, which means that is composed of different dimensions. The dimensions are income, employment, health, education, housing, crime, and the environment. So you have 7 numbers plus 1, which is the health, is the composite score, the AMP, right? So for each area, you have those numbers, and then you have the recognizability scores from the game. So you know to which extent that area was recognized by people in the game. If that area belongs to the collective map of people. And what you see is the direction of the correlation between recognizability scores and socioeconomic conditions. They go in the direction that Milgram and Kevin Lynch hypothesized. That is, when you have highly recognized areas, those areas tend to enjoy good housing conditions, living environment, good income, employment, health. The interesting stuff is not only that the direction is going the right direction, and certain correlations are quite strong, in terms of 64 is quite strong in this stuff, but also that most of the times there are certain aspects that are more important in terms of recognizability and quality of life than others. So, for example, housing and living environment are far stronger in terms of correlation compared to crime. And yet, in most urban studies, the aspect we study the most is crime, because data is available, because for many other reasons, and the whole thing is biased because of that, not because it's more important, but because it's more measurable and there is data around. So do you have any question on this part? No. Is all clear or is all... Oh, I need to restart again. All right. So one question that might come up in your mind is, and that came up as a critique when I was presenting this work a few years ago. I was like, okay, fantastic.
So if you're switching topic, I have a question.
Yeah, similar, but please go ahead.
Are you studying this statically or also the dynamics?
Okay.
Example, gentrification.
Yes. So the main goal of the project, which we failed, was to study the impact of a large-scale intervention before and after. So we did the game in the time that, not a random time, in the time before the London Olympics. And then the London Olympics involved 4 different boroughs. And what we wanted to do is to measure recognizability before the London Olympics and 6 months after, right, to have a sort of metric. And we didn't have enough data after. So we noticed some differences for one borough, but not for all the 4, because we didn't have enough data after the Olympic Games.
So you would expect that also, let's say, slow dynamics change will be tracked by this technique, and gentrification is something that's over years, right?
Yes.
That neighborhood change, social. Do you think that would be able to capture?
Yeah, I
maybe
mean,
early signals of that?
Totally, right? So I mean, so if you think about the idea also to having the Olympics, or to build an iconic tower in an area that is done by the famous artist in an area that is deprived, the idea is that to drive traffic of people that don't usually go there, right? I guess in Milan is the same thing,
Yes,
right?
exactly.
So you can definitely measure, and that was the hypothesis, that before and after you have totally different levels of recognizability. And all of a sudden, a gentrified area tends to be in people's minds, right? Did I answer?
Yeah.
Cool. Any other question? Are you getting bored or? Oh, all right, cool. Just checking. So some people say, okay, so basically you're taking some pictures, you're taking the score of a game, from a game, right? So basically what I'm doing is that I'm taking a recognizability score of an area, and the area is represented by different Google Street View, with different images, right? But I'm not looking actually inside the images. So I'm not looking what people recognize, right? They recognize an ugly tower, they recognize a beautiful tower, and so on. So we thought, okay, let's look inside the images. And we had back at Yahoo, some people that were working computer vision, so we could do that. But to me, it was like, okay, why would I look at inside the images? What's the interesting question that you can answer? And one question is, you know the concept of capital, right? How many capitals do you know? Well, yeah. No, capital, sorry, like a steady capital, so something that you own, right? You own something, you own a capital.
No, okay.
Capitalista. And so that form of capital is an adjective to that. It's money, it's financial first, then there is the part of social, right? So you know the right people, so you get the right connections, in a way, translated. Knowledge capital as well is a thing. So you can imagine that not only individuals possess this financial, I've got money, I've got connections, and so I have all this capital, but maybe I have also neighborhoods like that, right? So certain neighborhoods might have a certain financial capital because they have a median income, right? So they have a social capital because they have connection with the city council, for example, better than others. And then we are going to say, okay, maybe they have an aesthetic capital as well. So a neighborhood is beautiful, and maybe attracts people also because it looks beautiful, right? So can we actually quantify this aesthetic capital? And actually, does this aesthetic capital exist at all or not? Then we will see that it doesn't exist, but and then it goes back to one of your answers, but I won't spoil the story. Okay, so have you watched the social networking movie? How many of you? A few? Okay, the social networking movie was the story of Facebook, how Facebook started, right? So you guys have watched, you know how it started. For those who didn't, I'm going to tell you that it started with FaceMash. So FaceMash, unfortunately, was in Harvard, where you're wearing the speaker proudly. FaceMash is basically asking students. Mark Zuckerberg started by asking students every week who is the hottest on campus. And it was doing pairwise comparison, right? So hottest left, right, left and right, left and right, and then it was publishing the top 10 hottest on campus. Sorry, that was the starting. But the idea here is that from a computer science perspective, from pairwise comparison, left to right, you can actually produce a ranking, right? So there are actually people, believe it or not, who do that on, right? So they go from pairwise to ranking, and there are different reasons to do that. And also formal ways to do that. So we did a face match for cities, not for girls. So face match for city would look like that. So you would ask a question: which one of these two neighborhoods is more beautiful, A or B, or makes you happier? Who says A? Don't be shy. Who says B? Or brilliant. So let's say, yeah, I picked those images because I knew their answers. But the idea is concepts that are totally subjective, like beauty, happiness, kind of things, what we are after, but they are not random. So there is a difference between being subjective and being random. Being subjective means that around certain elements, consensus is going to emerge. Around other elements, you're not going to have consensus because it's a personal taste, right? So we're after unearthing the consensus. So we did again, where we don't have one picture but two. So not much of a change. And we ask people, which place do you find more beautiful, left or right, left or right? Which place do you find more, makes you happier? Which place do you think is quieter? And then once you answer 10 pairs of questions, it recommends you places, hidden gems in the city you can visit that are similar to the ones you like. But the point of this game for us was not like to do a recommendation algorithm or a recommendation system, but to actually get the data from people and say, okay, from pairwise comparison, remember, you can do a ranking. So you can rank by beauty, by quietness, by happiness. That's what we were doing. Okay. Great. So then, with computer vision, we extract some visual features, so things that emerge from the images, and then we correlate with the beauty score with the happy score, right? So if you do that, you can look at statistically significant correlation of positive and negative. And you know, the positive ones are the things that people tend to, well, the positive ones are things that makes people happy, on average, or Londoners happy, okay? And the negative ones are the elements that make Londoners unhappy. Right? Yes, you're with me? Okay, good. So, look in the paper, it's called aesthetic capital for the details because there are beautiful red dots that is going to mark all the elements that are statistically significant. But here I'm going to give you the answers. So, what makes Londoners happy? Victorian red brick houses and greenery, right? So, those are the top two elements that Londoners are going crazy about, visually speaking. So they're interesting as well because Victorian red brick houses actually is a culturally dependent thing, right? So you wouldn't find the same thing here in home possibly because we don't have a lot of Victorian houses, of course. But gardens and greenery is actually a universal element. If you were to repeat this game in other cities, you would find the greenery is actually one of the top elements, right? And you can intuitively think about it. So what's the worst element? The strongest negative correlation that we found, visually speaking.
Did you study the cultural aspect? Because if you ask a Chinese person, he would
Yes.
possibly tend to favor the climate.
Yes. Yes, yes.
I think in a multicultural city like London, that would maybe yes.
Yes. I'll tell you. I don't have the results, but I'll tell you later. But definitely, that's the main point of this study. So, yeah, what's the worst element? What's the most negative? Just have a guess. Oh yeah, good. All right. So cars, right? And we've been knowing that. I mean, we've been planning cities around cars as well. Think about, well, I'm not sure in Italy you have another example, fortunately, but I mean, in the US you have to include that way. And Christopher Alexander, who is an urban planner, he wrote the pattern language, and pattern language there are patterns that, like a programming language, right? So you mix them up to actually do desirable things or undesirable things. And cars clearly are undesirable. And he writes, cars give wonderful freedom, you can go from one place to another, but they also destroy the environment to an extent so that they kill all social life, right? So if you have fast-moving lane, you know that there is a psychological difference when you're going to go through the street. I mean, is interesting, right? And we found that as well on the data. So, but the good thing of this data is that you don't only look at on average where there is agreement, but you might look at outliers. So you might look at Google Street View where you have a car and yet people consider it to be beautiful, or that view makes them happy, right? So you can look at outliers. So cars are not that bad when they are not cars. So when cars are parked on small streets, they are out of the way, slow speed, then they're totally fine. So it's more to do with traffic and the psychological impact of traffic rather than the presence of cars. So that speaks also to the fact that where do you plan to have a parking lot, for example. Right? So in US, it's pretty typical that you have two buildings and a parking lot in the middle, worst thing you can possibly do, right, in that case. Okay, so then the second worst element was isolated buildings. That was another thing that Christopher Alexander also wrote about in the 70s. His evidence showed that high building make people crazy, and then he went on describing the literature, the mark showed that. But then the other thing is that, again, you can do the same kind of game, right? So you can look at when you have outliers, when you have high buildings that still people consider beautiful. And those two examples, the top two, the outliers are in London, glass offices and landmarks, right? So glass offices, again, is a culturally specific thing. They give London its unique identity. Whereas landmarks is a sort of universal. Again, if you were to repeat that in other cities, they would be considered at least useful, if not beautiful, right? Always. Why? Because the way you navigate the city is by landmarks, right? So that's the main way that you do that. So all of a sudden, we were after something that is what is aesthetically beautiful. And when you actually connect all the stuff and you have other elements in the paper, but even from the few examples I gave you now, you can clearly see that the negative parts, cars, isolated buildings, public gardens, and small streets, they are positive ones, they have a difference. And the difference is not the way they look, is what they are for, right? So do they increase the potential for social interactions? Yes. Then they are considered to be positive. Do they decrease the potential for social interaction? Then they're considered negative. So there you have a rule of thumb, but where when you do maybe planning of addition or subtraction of elements that you can use to say, does this element increase potential? We're not talking about actual social interaction, potential for social interaction. Then maybe it's a good element to have, right? And that also speaks to the fact that it could be also indoor. But the point is that maybe this aesthetic capital doesn't exist at all. It's nothing to do with aesthetics, it's more to do with the social capital, which is the formal capital that you mentioned. Then, the other thing that was important, and that was to answer your question, was so most of the studies in sociology, especially in the US, they focus on the fact that, for example, different races might perceive the same neighborhood in totally different ways. So what a Latino perceives is different than what a Black American, might perceive. And for example, in the game, you get to show 10 pairs of pictures, and then you answer a survey afterwards. And in the survey, we ask how many years you have lived in the city, your postcode, to know your area, and your racial background, your racial, gender, and your profession. So in terms of, we could see that, for example, so we could see many differences in terms of gender, for example, but yes, in race, right? And race is more like to do with they use the people make the spaces. So in certain culture in the same city, you might have the use of the park that is totally different. For certain culture, it might be that I don't want to go in racial profiling, but for certain culture is you go to the park and you play whatever, right? football, volleyball. For other cultures, they do picnic in there, right? So the perception of that was shaped, the aesthetic perception was shaped by the use of it, right? So we found those differences, but not in terms of gender, and in terms of profession, we were not, we didn't represent the general population, so we had simply bias, right? So we had many more people who were interested in urban, interested in technology than the general population.
I think there is also a correlation with the general human development index. One of the examples that come to my mind is the previous expo in China. There was a promotional video that to a European eye would see just oral. The scene was a family that was living, let's say, in the countryside. We had what we would regard as a very idyllic, let's say, context, and then the family started to the big city, and then you would see car traffic, development, all sorts of mess, and the message was, wow, we're gonna travel towards progress.
Yes,
so
yes.
exactly the reverse of the mental process that one of us would do, because we have been living in that mess for.
Exactly.
That would be very interesting, let's say, correctly, and also in Italy, where aesthetic capital is something that seems to have a correlation with people happiness. I mean, if you are poor but you live in Salminiato, there is still something that has to do with beauty that may alter your perception.
Yes, yes.
Of your stuff.
And
do you plan to replicate this in a country like yours?
I mean, the aesthetic, we don't have the resources to actually replicate it, but the previous one, the recognizability, we can replicate it straight away. We replicated already for 20 cities. For example, in Brazil, we found that the recognizability of central areas is not that important because, especially in São Paulo, in central parts are actually the ones that are more deprived. So the actual mechanism is the opposite than in western parts. And the other thing that is similar to your example in China is being, so one person from India, she looked at what I said about the aesthetic of the cars, right? And she said, but actually we want cars, right? So that's our status symbol. That we are going towards that. So why you're telling us that we have to build cities without cars, right? And that speaks to your example that there are confounding factors in there. So, but then it gets, oh yeah, go ahead.
One personal doubt.
Yeah.
Do you notice some correlation between actual information on the image, some artistic characteristic of the image, for example, the rule of thirds or the histogram of the image? Did they give you troubles to filter out this psychological bias? Yeah.
So the histogram, you're not speaking about the color histogram, right? So
no,
just
some situations, if you have an image that has flat histogram, best histogram gives you a better impression. Or, for example, there are people that think that picture taken with a phone are better than a picture with a reflex because they have a higher contrast or information like that. Did that give problem in the experiments?
Yeah, that's a main problem when we started because we wanted to control for those, right? So you want to control, and then you want to have the results that keep those factors constant, and then you want to have the results independent, right? So yeah, that's the main reason why we went for Google Street View and not Flickr. Because, but actually, the first day when we started the project, I thought, let's go for Flickr because we have tons of metadata. But the problem then it gets reflex, the type of color, then the angles with which you take, the type of things.
You have professional like pictures,
exactly.
Pictures taken by a casual photographer.
Exactly.
Totally different.
Totally different.
Even position, if you take the Brooklyn Beach from a good point is amazing. If you go below it, it's
yes, that's true.
So it depends.
That's true. So I mean, that there is a detail in the paper. So we go for Google Street View, right? So the idea with Google Street View, you take it the same focal point. The Google card goes out with the same weather condition at the same time of the day for the whole city. So they try to normalize all this stuff. So we had already that kind of thing, normalizing that. Then, in terms of computer vision, we actually control for example, image quality. It might happen that it's a small number of Google Street View that might not be comparable with all the others. It might happen that, and we control for it. It might happen that you are below the bridge, for example, you can't see anything. So the other thing that we control for is that for each point, we took the Google Street View of in that direction and 180 degrees on the opposite direction. and we check the reliability score for that point. If it wasn't reliable in both ways, then we would discard that point. Any other question? Okay, cool. So then imagine just as a thought process that those points are points on a map that you review, and you have scores that are beautiful, recognizable, makes people happy on average. So what do you do with points on a map? Well, since we're geeks, we connect them. So in Yahoo, we build a new mapping tool that instead of giving you the shortest path from A to B, is going to give you the short path that makes you happier, is more beautiful and quiet. So instead of walking 20 minutes, you walk 22, and you have a totally different experience. So, and you can do that automatically. There you go. So we tell you the paper shortest path to happiness. Details in there. So in that paper, apart from connecting points and doing distra on that, what we did is that we tried to do a generalization. So can we actually use Flickr pictures and the tags that are around the city and trying to predict the scores that we get from the game? Then we do a model in London, and then we apply that model in other cities, like for example Boston. Would that work? Right? That was the question. So we tried to do that, and the generalization is done as I was telling you each picture in Flickr. There is your reference, your tags. From these tags, you can say this location, the game told you that this is beautiful or is ugly, and then can you actually associate those tags, and then automatically you learn a model that associates tags to predict the scores of beauty and happiness, right? Okay, and so we ran 2 experiments. So we also people in London and Boston, and we asked them in different situations, would you actually go here if you had to, I don't know, if you had an Italian friend over and they would walk, you have to walk in beautiful parts of the city, which one would you choose, right, among the 6 different paths? And then we choose one, then we ask about perception of length and these things. So the main result of these studies was that, wow, can we actually do that? Because they actually didn't perceive any difference in terms of walking time between the shortest path and the short path, right? Because it's 10% max longer than the shortest path. First. And second, they said, okay, well, this is much better. So why companies are not doing that? So why Google is not doing that? That was the main line that came out. But also, I mean, apart from being surprised that this thing could be done in the city where they lived, the thing that they said was specific example of things that were missing from the past, right? So people said, yeah, I would take this path in my city, but it smells in a certain way, right? I go through Chinatown and then go through Italian district. It might smell different, so I might take that path as well, or might not take that path. So they were speaking about smell in a positive way, a negative way. They were speaking about sound, and they were speaking about memories, right? So sound, you might imagine, there was a girl doing running and synchronizing with the church bells, the run beat. And so that was her daily habit. And memories, the typical memories, a guy said, this street is really important to me because I gave my first kiss here, right? And that was like, okay, it's important to you. Maybe it's not important to the world, but you might imagine some memories that were mentioned by, for example, journalists in Fleet Street in London, where you have all the newspapers, the old one. They say, oh, this Fleet Street is really important to me because it's my profession, it's my thing, and it's historically important, right? So that might be, so the point is, not only what you, so you stand on a street, not only what you see is important in terms of your psychological perception, but what you smell, what you hear, and what you remember, right? What are the memories that you have? So we thought, okay, let's study this stuff, right? So let's play some sensors and let's look at smell, possibly. So basically what we are trying to do is that we are trying to do a layer, right? So the layer of sight, for example, what people consider beautiful in terms of vision, but then what they smell is important, apparently, right? And that's what they told us. And the people I was working with, they thought, well, are you crazy, right? So are we really working on smell? We have to deliver in a quarter, and it's really difficult to actually capture smell with sensors, and it's costly. How we're going to do that? And why, in the first place, we're going to look at smell? Because nobody cares about smell anyhow. So the problem is this. So this is the same place in 2014. There was doing some back-envelope calculations based on your receptors. And actually, if you look at your nose, it's a big data machine in a way, right? So in a way, in principle, then you don't do it because you are going to go crazy. But in principle, you could distinguish 1 trillion different kinds of odors, depending on your receptors, right? So that's a huge number. So it's going to be 1 trillion, 1 billion, 1 million. Who cares? But it's really huge number. So there is a huge potential in your nose. And yet, if you go to city planning, in London, for example, you have one person dealing with odors only. And this person usually deals with bad odors, right? So imagine that this gigantic pile with 1 trillion odors, and this guy is dealing with 20 odors usually. Why is that? I mean, the answer is easy. My questions are really basic sometimes, too basic that you might think, no, it's not right. So why the city council deals only with 20 odors out of the 1 trillion minus 20? So this is the obvious reason.
Sensors, and people complain about that.
Exactly. So the way of sensing odors right now, this is the state of the art in the city, is through complaints. So you have human sensors around. If you complain, we fix it. That's the state of the art. I mean, I was expecting you to be a bit more surprised, but it's good that you're resilient to surprise. But so you have human sensors complaining, and of course you look at the pie, and then you have one line, and that's the complaint bit, right? So the good stuff is like we don't care, we don't plan for the good stuff. Okay. Of course, you can go and you can go around with these nasal rangers in US and in China as well. They go around. Don't ask me how they work. I think they work as an amplifier, and I use it for policing reasons. But clearly, it is not totally scalable, right? And then there is another problem. If you look at the architecture and urban planning, actually the first PhD thesis was a few years ago, was written by Victoria Nenchon, about urban smellscapes. How do you basically plan the city through odors, through smell? So that was only 2 years ago, right? So, I mean, there is not been a lot around the planning for smell, just because you can't measure smell. That's the truth of it. Okay, we said, okay, we can measure it. And I went to a party, I met Kate. And all of a sudden, after a year, we were thinking about this project with sensors. She said, oh, actually, I do a PhD in the Royal College of Art. She's an artist. She does a PhD in smell. Okay, I said, okay, I need to talk to you. And she explained what she does. Basically, she goes around the world and for a PhD, and she asks people to smell stuff. So people from Amsterdam, she picks people that are local, and she designs some walks, and she says, okay, let's smell things, report what you smell, the descriptors, and then tells me whether it's expected, familiar, and pleasurable. Those are the three most important variables for smell, right? So basically, she had all these Excel files around the world, going around the world with Excel files with smell descriptors. So what we did, we partnered with her, and we said, okay, let's put it together, right? And we put it together at her word, and why we did that? Because what we have, obviously, so we have Kate, the textual descriptors, right? In the previous project, you saw that we have Flickr data, for example, right? So we had Flickr and Instagram data, they are textual descriptors again, right? So we can match the two. And that's what we did. So why is that useful? Well, it's useful because, first of all, you can give categories, and you can categorize the words of the Kate collected over the years. So how can you possibly categorize them? Okay, so just imagine, this is just an example, no real numbers, but just imagine a graph where all the nodes are words in the Kate graph. So just imagine that all the words that Kate had for urban smell, they're translated into a graph, where the nodes are words, and the connections are expressed the number of times the two words co-occur together. For example, the co-occurrence graph, right? So for example, viral roads, the co-occur 50 times, viral means something else 12 times, and so on, right? So you build the co-occurrence graph. Why? Because if you do community detection on that graph, then you can actually find some categories and subcategories of things, right? So you basically groups, yes, okay, cool. So yeah, you can see the community structure emerges, and then when you're going to see the data, you're going to see that all words related to animals, they cluster together, nation words, nation words. That's basically the conceptual idea behind it, and that's the result. So those are example words, not all of them, because there are 380 words, or relatively good now. Those are example words. For example, is metro, and is in the category metro. Or nature, you have floral, that is into flowers and plants, and then you have nature, right? So you have basically categories and subcategories. So for the first time, you can actually have a dictionary that represents an urban smell, and each word has got a category and subcategories, and you can do the analysis at the level of category. Why is that important? Because if you look at single words, that's it's like producing info porn, right? So you look floral, okay. Then you have a spike in a certain part of the city because someone is a florist, right? So it's not very useful. Whereas if you look at the level of categories like nature, traffic, and so on, you can actually describe pretty well a street segment in a robust way. And on top of that, you have not only the negative part, but you have also then the positive part. So for the first time, you can actually map the positive part of it and not rely on complaints. So, okay, we're showing the dictionary. I think it's been translated into 8 languages at the moment, 2 different projects. Of course, some people might say, okay, this is a bit crazy because people on Instagram and maybe on Flickr, there are a bunch of hipsters. So, of course, you have the hipster London in London is East London. So there are tons of hipsters. So you have tons of Foursquare check-ins and Instagram pictures. Of course, there is a huge bias, right? So what we wanted to do is we wanted to ascertain the more or less our result, the street segment level, that were more or less right. So what we did is we worked with the epidemiologists in London and Barcelona, and for each street segment we estimated, for example, nitrogen dioxide, right, which is an air pollutant, for each street segment for all the city, and we looked at correlations between nitrogen dioxide, for example, which is the first column, and presence of a certain cluster of words. And what we found, the strongest correlations are 2. One is negative, one is positive. The negative one is emission. So, no, it should be positive. Yes, it is positive. With emission, the red one. So basically it means that you have a lot of nitrogen oxide where you have words that are related to the emission category. Right? And you have negative correlations of nitrogen dioxide where you have nature related categories. Right? So that is going to tell you with this kind of correlation that more or less on average, yes, there is geographic bias, but on average you're describing the city pretty okay, right? I mean, to a level that epidemiology would do. So just to show you an example and then to conclude because we have no much time left, right? So I mean, this is just an infographic to show you that you look for one category, that is traffic, and you look at all the words related to traffic for the map of London. You can do that for all the other 9 categories. This is nature, and you can map the nature category for London. Can you see the river over there? No. Oh, yeah. Okay. This is food category, for example, and then you can map the foodscape of the city, which is blue, I'm not sure why. So we call this project.
Wouldn't you correlate the food smells with, let's say, TripAdvisor?
We did correlate with OpenStreetMap. So presence of restaurants, presence of nature, presence of country.
Because TripAdvisor gives you also the, let's say, type of cooking. Interesting as a subcategory of food.
The type of cooking, yeah, you can go in the subcategory of food. Yes, definitely. Yes, you can do that. Yes. From definitely yes. Also Yelp in the US might be another point. Yeah, and then the other, oh no, you're not starting again, right? Yeah, basically, why is not there? Okay. We call this project smelly-maps, and if you go on goodcitylife.org, you can actually go on the map of London. There are other cities, including possibly Milan or Rome. I'm not sure. Maybe Milan. So you can look, you can click on each street segment. You can see the smell profile of the segment. Now we added also the emotional profile because you can extract emotional tags as well. So you can see emotion expressed on average. And this is a 10 years worth data set. So collated, that's why you can get that kind of resolution. Right, and then yeah, you can look at red is traffic, green is nature, and yellow is animals, and you have a big cluster usually at the zoo of animals. And, okay. And we did the same thing for sound, right? So the methodology is slightly different in terms of collection of sound data. We call it chatty-maps. There is a paper, there is a wheel as well there, and basically the idea is that we are adding layers, right? To the same city, we're looking at sight, visually beautiful and happy, smell, sound, all the emotions. And then what we want to get is to a new layer that is about well-being, right? So if we can get the well-being data of people, the health of people, then we can relate all these layers, psychological perceptions, and the well-being of people. So that's the result of this, and that's why maybe a company might be interested in that. Might justify our presence. So these things have been around. I mean, we publish our papers in okay places, in good places, but we also, I mean, we were in different museums. So we were in the infographics thing. 2016, so it's a book that collects all the best infographics around the world. And some people might say, okay, fantastic. By looking at this thing is cute, right? So because you look around and then done different font and form methods, it's very cute. Actually, I'm not sure I would choose a project because it's cute. I like cute projects, but I generally choose projects because they are shift. And the shift you can clearly see, for example, from the example I gave you about smell, right? Smell, state of the art, is like complaints and looking at one line in the pie. Now you can look at a pretty substantial part of that pie, also the positive side. So to me, that, for climate, for example, is a total shift. And the shift there is actually coming from social media. So data that is produced by people taking pictures for totally different reasons. And now we're using that data for totally different uses. And that data, in theory, if the API is open, is free, right? And we can have also free projects like OpenStreetMap that can be used for that. And of course, you need to get your hands dirty. It's not all about Hadoop, it's not all about algorithms. It's also like going around with networks. It's also going around and asking people the way they perceive things and so on, to do user studies. So it's really multi-stuff, right? And what it gives is a new language. So we find that we collaborate with people that are artists, we collaborate with epidemiologists that want to do like random sampling of different parts of the city because the devices are expensive, they're difficult to move. We are collaborating, for example, with Vogue magazine in Brazil. They did a scratch wheel for the city. So you collaborate with all sorts of people. They are looking at the same work, but looking in a totally different way, right? So that to me is something that I like from this stuff. So, I mean, if you want to know more, you can subscribe to the mailing list there in goodcitylab.org, or you can actually crush the server by clicking on the maps. All right, thank you very much.
Thank you.
Regarding the happiness of the past, I can imagine that one criteria would be the crowdness of the past
Yeah.
itself. Don't you think it generates kind of a curious paradox, the fact that the past is happy because no one knows it's happy?
Yeah.
Or in other terms, let's say that every citizen of the city starts using your application tomorrow.
Yeah.
Those happy passes probably will not be so happy with all the people going there.
Yeah.
It will kind of ruin itself.
Yeah.
What would you do?
Yeah. So basically, I mean, the algorithmic answer has been solved, right? This is exactly the same problem that if you were to use TomTom or Waze, for that matter, does, right? So it does load balancing across the city. So you don't want many people, as you say, rightly, you don't want many people to actually go on the happy path, but you can find K paths that are happy or similarly happy, and then you have to load balance people. So you can solve the problem with that. But, so fine. But there is a worse problem to that, which is related, and is about at the level of areas. Once you look at the level of areas, then that's a huge problem, right? So you might say areas that are okay and beautiful, and you route people on those areas, then they will be reinforced to be beautiful. Whereas areas that tend to not be that beautiful, they are reinforced to be less beautiful, right? And this reinforcement for city council is a big financial loss, because if you have to compute, so if you had to revitalize a street that had 3 shops, and now all of a sudden does have 0 shops, this is going to be a huge financial cost for the city council. It would be even better to finance or subsidize one shop to keep it open, the street, than to let it go, right? And that's a big problem of this kind of technology. But, for example, in Barcelona, we did a sort of small study where there were areas that people wouldn't go because they didn't find particularly interesting, whereas we built basically happy paths in those deprived areas. So we did an experiment of people going through those areas, and they say, I've never been there in my city, but now there are still beautiful parts. So I wouldn't say technology is neutral, but you can put on top the technologies the way you use it that makes a difference. I'm not sure I answered fully.
Yeah, I mean, that possibility is because I was speaking also based on experience, like for example, on your image, on New York, there's the skyline, which is the green pattern of the city, which is one of the best walking experiences in my life. Yeah. And when I hit it on a bad day, it was absolutely the worst walking experience in my life because it was like fish inside a can, basically, and it completely ruined everything. It was an awful experience. So whether you are replacing this product.
Yes. So definitely in the happy paths, you have to load balance, right? But I mean, even a simple thing, I always suggest, so I suggest a student to do this study, but they've never done it. To map, basically, the simple thing is the density in a space of people and the perception of that space. So think about the metro. In a metro, in a train, you have a different perception depending, I mean, I assume, I don't know, because there has not been research, your perception is a sort of existential-like in the sense that after a certain number, then your perception is going to be totally ruined, like your perception in the skyline in New York, right? So doing this study, because we can get crowd data, we can get passenger data, number of passerbys, right? So we can have formula that will convert into expected perception. That would be a fantastic project, and I'm not sure it would be very difficult to do, right? So if you guys have time, maybe we'll explore the option. Yes.
There are international rankings on happiness of cities. Do you think that could be a ground truth for your approach?
Yes, if we had a way of comparing different cities with the same metrics, right? So
they have, I think, also the ground measurements that make up their aggregated scores. So there are panels that check different measures, and then they make these rankings. They have the value that they have. But at least they are backed by some, let's say, institutional body. Have you ever cross-checked your, let's say,
in this work, not, but in other words, yes. So we did work on, that is not published yet, but work on 25 cities around the world. And I mean, the problem of this stuff is that in social media, so social media doesn't work everywhere in the world. So you have developing countries where it doesn't work. So what we did is we collected Google Places data. So POIs, basically, that you can collect from OpenStreetMap as well. And then we were trying to figure out, can you extract metrics out of Google Places and POIs that are about walkability and things? And then you have metrics that are neighborhood level, but also metrics at city level. And then we have 25 cities, and you can compare the city level metrics with each other. And then we checked with the ranking of the economists, for example. The economists are the well-being index for cities. So yes, but definitely you need a way that is normalized at city level, so that Rio can be compared to Milano, right? Yes?
So there's one question about the seasoning influence of the because in all your pictures you just see some river and everything is obvious and you can see everything, but if you consider just it's winter. You don't care about the snow, you don't care about the other, you just care about either, you know? You just want to walk and push a point into economy. So did you consider this seasoning influence on your research or not? Just consider the same season for all the cities or just for a single city and just have a study in one season or just maybe for a year?
Yes. I mean, we consider, unfortunately, I don't have, but I had some interesting examples maybe here. Because I have, well, unfortunately, I don't have this example. But anyhow, yes. So there are two problems, right, in underlying your question. One is I want to get there, so I'm goal-oriented. I want to get fast, right? So one point that we took into account in the path work was that the maximum. So basically, how it works is that you do A to B, and you find the K shortest path, right? And then you explore all the K, and you see when you have basically saturated happiness, let's say, right? So, and you have a threshold. Maximum, I think the maximum is 20% extra walking time. So the algorithm cannot propose you something that goes above that. That's totally unacceptable. So even in a goal-oriented fashion, and we actually found in the study, the people can distinguish the difference in a 20 minutes path between what is shortest and what the short one is. First, the second, seasonality is important. So actually we published an entire paper on that, on the smell and seasons and colors and things. And one thing that we found is basically a way to say, can you actually give a sensory experience at different seasons? So what they never thought about, but came out from the data, is that you have a certain experience in the summer, right? That is in London, you go to park and so on. But then there are also things that are considered pleasurable in terms of smell in autumn. And one thing that came out was soil from the data. So we have now a tool that will say what's the best experience in autumn is soil in terms of senses, and you have to go to Hampstead Park to fully experience that sensory perception. So you can actually have this data that you can go through seasons. I can say what is the best experience for that season and where I can find it. Then in Como, I don't know whether it's so diverse that you can find that seasonal experience.
Smell, for example, is very characteristic of wine. It's very different.
Across seasons. Right. So, but that's, did I answer?
Yeah, because you know, for sure, in this type of study, you don't care about the kind of the effect of each characteristic on your choosing the best time.
Yes.
So that affected for sure the seasoning in one city or the weather. Sometimes it's unpredictable, basically.
Yeah.
So you would say that maybe it's a random choosing best.
Yes.
But anyhow, it's kind of you can say it's outlier for those systems. But I just want to know that did you go through this aspect?
Yeah. So we went through, and also you need to think a little bit. This thing is the average, right? So another work that we published last month, right? Wisdom was about contextual path recommendation. It was all about can you introduce time and weather condition in the path recommendation. But you can see where we are going, right? So, I mean, ideally, in the ideal world, in 5 years' time, you're going to have enough data to actually personalize that, not only to the time and to the weather, but to you and to the way you feel. Because your watch is going to take, like my watch, is going to take the blood pressure, and it's going to take maybe in 5 years. It's going to take
steps.
The speed of yeah, the steps, my blood pressure, how much I'm sleeping, how much I slept yesterday night, 4 hours, not much, right? So he's going to know all this stuff, and he's able to actually say, I'm going to personalize to your studies right now, right? So we're going there, but we don't have enough data for the moment to actually show that.
It's a great map.
Yes.
One remark, it's a pity that our colleagues from the map project are not here because they are tracking path with their accessibility level. So suppose that you are an impaired person.
Yes.
You could have a very good support. Suppose you are blind, for example. A mix of, let's say, happiness due to smell and rumor would be great.
Yes.
Or a layer where you track the path also to show that it is more accessible than another one.
Yes, it's totally emphasized because they use those senses versus another. And plus, so now, of course, I mean, if you look at sort of like a child, right? So you look at the layers, it's what you see, what you hear, and then what you touch. And now we're trying to explore where through computer vision you can have touch. And touch is very important, for example, for blind people, right? But, I mean, the results are not great at the moment for that project, but I think it's going to be a touchy-map somewhere. It's going to be, we don't know exactly for what, but yes, possibly yes. Any other question or comment? Perplexity? No. All right. Cool.
Okay.
Thank you, guys.
Thank you very much. Thanks for attending.
Thank you.
Thank you.
Thank you.